When we look at a building, we tend to think its main job is, well, to not fall down. And sure, that's important. But the real secret to great design is something you can't even see. It's all about controlling the natural bend, or what engineers call deflection. This is the hidden science that makes a building feel solid instead of shaky, and that's exactly what we're going to get into.
So ask yourself this: what really separates a good building from a truly great one? It's not just about being safe, it's about how it feels to be inside. You know the feeling, right? Some floors just feel rock solid, and others have this weird, bouncy feel to them. It all comes down to managing something that's happening right under our feet all the time.
I mean, let's be honest. Whenever you hear about structural engineering in the news, it's usually because something went terribly wrong. A bridge failed, a building collapsed. And of course, preventing that kind of disaster is the absolute bare minimum. It's job number one. But here's the thing. That's just scratching the surface. The real genius, the thing that separates everyday design from exceptional design, is managing something that happens long before a collapse is even a remote possibility. It's all about the bend, this tiny, almost imperceptible movement that's happening in every structure, all around us right now.
Okay, so this bend, what are we actually talking about in engineering terms? Let's put a proper name to it, shall we? This brings us to the core idea of our whole discussion, defining deflection.
So, in the simplest terms, structural deflection is just the amount something bends when you put weight on it. Think about a floor beam. The load could be people walking, all your furniture, or even just the weight of the beam itself. And I want to be super clear here. A little bit of this bending is completely 100% natural and expected.
For a perfect, everyday example, just picture a plastic ruler. You lay it flat on a desk, you push down right in the middle, and it bows into a curve without snapping, right? That curve, that little dip from its original straight line, that is deflection. And believe it or not, every single floor you walk on does the exact same thing, just on a scale that's way too small for you to see.
So, a tiny bit of bending doesn't sound like a big deal, does it? Well, not exactly. When that bend isn't kept under tight control, the consequences start to become very visible and, frankly, very annoying. And this is a really, really important point. We're no longer talking about the building falling down. We're talking about problems that mess with your day-to-day life, making a space feel uncomfortable, cheap, or just broken.
Just think about this chain reaction. Have you ever seen one of those nagging hairline cracks spread across a ceiling, or a door that you have to shove to get it to close properly, or, and this is a big one, a floor that feels more like a trampoline when you walk across it? These are all classic signs. It means the bones of the building are moving just a little too much, and the brittle skin, the drywall and window frames just can't keep up.
So you might be thinking, is all bending bad? And the answer is a big fat no. In fact, engineers design for a very specific, calculated amount of bending. This is what we call acceptable deflection. It's totally fine. The real enemy here is excessive deflection. That's the point where a controlled, invisible bend becomes an uncontrolled, visible problem.
Okay, so if some bending is okay but too much is a huge headache, how in the world do you control it? How do you get it just right? Well, that's where the real engineering magic happens. And here's the surprising part. The solution isn't just about making things stronger so they won't break. The real art is designing for something engineers call serviceability. It's a fancy word, but all it really means is, does the building do its job for the people using it every single day without being annoying? Let me put it this way. Strength is about surviving the absolute worst-case scenario, like a hurricane or an earthquake. But serviceability, that's about thriving in the everyday. It's what makes sure your floor doesn't feel like a diving board and your walls don't crack. And in a great design, you absolutely cannot have one without the other. They are equally critical.
So how do they guarantee this serviceability? What's the secret weapon? It's something called deflection limits. These are basically strict rules set by building codes that say exactly how much a beam or a floor is allowed to bend. For instance, a common rule is L over 360, which just means a beam's bend can't be more than its length divided by 360. It's a precise mathematical guardrail that keeps everything feeling solid.
All right, let's bring this all home. After all that, what's the one big thing you should remember from this deep dive into the science of the bend?
It really just boils down to this. Great structural design isn't about brute force. It's not just about stopping a collapse. It's a delicate dance, a balancing act between having the ultimate strength for emergencies and having the right amount of stiffness to perform perfectly every single day. And that's the whole ball game, right there. A truly great building doesn't just survive, it performs flawlessly. It feels solid, it works perfectly, and it stays free of all those pesky cracks and sticky doors. It's about creating a structure that doesn't just stand up, but one that stands still.
So here's my challenge to you. The next time you walk across a long bridge or stand in a huge open plan room, just take a second. Think about the incredible invisible engineering happening right beneath your feet to control that bend. Because now you're in on the secret. You know the science that makes our world feel solid.